This is a demonstration of our Core CT Circle Plaque software. This is server-side process, so when the data hit the server, the center lines have been dropped down the vessels, the vessels have been segmented, and also the plaque analysis has been completed. We open with Core CT. You can launch either a retrospective or a prospective gated data set. This data set I'm loading is a retrospectively gated data set. When it loads, you can change the 3D image down below into the coronary tree. I suggest you do this because this is really the key to vessel analysis, is to make sure you're in the right phase. So since this is a retrospectively imaged heart, in the upper left viewport, down in the bottom left, is where your phase selector is. And if you look at your coronary tree, as I take it through the phase, you can see that I can take the uh, vessels away because they're out of phase. In this particular data set, the 80% phase is the best phase. Bring your attention to the top right. The red exclamation point in front of each one of these vessels indicate that a lesion has been found. The next tab over is the CMPR tab. When we click that, we'll see that we have segmented. The right coronary artery is first, then the LAD and the circumflex over here on the top right. And you can see that the computer has found a lesion. To highlight the lesion, just click on the distal marker and it will highlight this. And let me explain how the computer will actually find a lesion. When you're looking at the vessel and the vessel wall, you have an inner and outer wall of the vessel. When they start to converge, that's where the proximal marker is placed. As you go down the vessel, where the convergence ends is where the distal marker is placed. We can calculate the area or the diameter of the stenosis by up here to right by selecting diameter or area. And the way the software works is they look at the convergence, they look at the minimum area of your proximal marker and averages it to the minimum diameter of your distal marker. It takes that average marker, that average number, and then in between the two markers finds an area of where that number is the smallest, and we'll put the red marker there. The dotted bar is your interrogation bar, so you can drag this up to look at that area to see if it's real. If it's not, you can move it to the place where you want it. And if you agree to it, we have a little green check mark here that will state that you agree with it. If you don't agree with it, you click the red X. So we'll agree to it, and that will open up our plaque tab down in the bottom right. As it's processing, it takes it just a second and we'll calculate our plaque. The plaque that we calculate is calcified plaque in yellow, non-calcified plaque in orange, and low attenuation plaque in red. We'll give you the volume of the plaque and then what percentage of that area is the percentage of the area that's involved in the calcified plaque, and it gives the percentage of each one of these. You also get an area stenosis. If we had it set on diameter, you would get diameter stenosis, and it also gives you the remodeling index. There might be an occasion where the proximal marker is up by the ostium and it might grab a little bit of the vessel. So you have the ability to take the proximal marker and remove it. Also, if this lesion here is fully occluded, you have the ability to mark it fully occluded. When you are looking at the distal and proximal markers, over here on the left-hand side, this top green box represents the proximal marker, the bottom one, the distal, and the middle one where your lesion is. We could go over to the LAD. The LAD has 2 lesions in it. We can put as many lesions as there are in the vessel. Again, it puts a proximal marker at the beginning of the convergence of the wall and ends it when the convergence ends with a distal marker. Again, you can bring your interrogation or your navigation bar, whatever you want to call it, up to that area and look at it. Now, when you have the navigation bar here, what you are looking at over here on the left now is a layer above and a layer below of what this is. And these little dots over here on the right-hand side are the layers. So the layer above this one would be this image over here on the top, and the layer below would be this image down here on the bottom left. You can go ahead and navigate up to it. If you agree to it, you click the green check mark, and you could do the same to the other lesion. Do the same exact thing. If you agree to it, just click on it. Now, there might be a situation where the computer maybe did not find the plaque, and you, as a clinician, may want to look in another area. So we can add more lesions. Up here at the top is the lesion tool. You can click on the lesion tool, come down, left click and hold, and it'll put the proximal marker down to the distal marker where you release. It will automatically process. And then over here on the right hand side, you can see that there's no values, so there is no plaque there. We can update the report. All of these values and images will populate on the report. And we'll show you the report here in just a second. So when we look at the report, the first thing I want to point out is that we have CAD-RADs. So this is where you can place all of your CAD-RADs and save them. And as we scroll down and we look at our coronary stenosis measurements, you'll see that we'll have them categorized: minimal, mild, moderate, and severe are occluded. Here we'll tell you how many lesions are in that vessel. Down below, it will tell you what the calcified plaque volume is in each one of those lesions, each one of the vessels. And I just want to point out that you notice the low attenuation plaque is indented below the non-calcified plaque. And let me explain why. The low attenuation plaque is minus 30 to 30 Hounsfield units. The non-calcified plaque is minus 30 to 350 Hounsfield units because the non-calcified plaque includes the low attenuation plaque. Then the calcified plaque is 350 Hounsfield units or above. So we have a total of the calcium or the plaque volume, and then the plaque burden is calculated by the area from the proximal and distal markers divided by the plaque volume will give you the percentage of the burden. That is our circle plaque.